In this video, we're going to look at comparing fractions with the same denominator or numerator. Shade the following areas representing the fractions using the rectangles below, and we're asked to shade 3/7, 6/7, and 1/7. So first let's write next to the rectangles what we're going to shade. And I'll use a highlighter. So this is our unit. It's cut into 7 equal pieces, and we want to shade 3. And I'm going to shade the leftmost just to be consistent, and so it'll be easier to compare them. 6/7, well, that would be everything except the last 7th. So we have 1, 2, 3, 4, 5, 6 7ths. And finally 1/7. And now we're asked to order the numbers from least to greatest by comparing the amount of the unit area shaded. Well, looking at these diagrams, since they're cut into the same number of pieces, we can see that this is the least amount shaded, which is 1/7. So we're going to write that first, comma. The next least amount shaded, or the middle one, is 3/7. And the last is 6/7. Okay. So now notice they all have the same denominator, and if you compare the numerators, 1 is less than 3, which is less than 6. So this will be one strategy we can use when comparing fractions. If they have the same denominator, or we sometimes will give two fractions the same denominator, we can compare them by just comparing their numerators. Let's look at the next one. Identify the fractions represented by the area shaded in the rectangles below. So, if this is the unit, we have 3 pieces and 2 of them are shaded. So here we have 2/3 shaded. Here there's 1, 2, 3, 4 equal pieces, and we also have 2 shaded. Here we have 2 pieces shaded, but there's 1, 2, 3, 4, 5, 6 pieces, so it's 2, 6. And finally 2 shaded, and there's 1, 2, 3, 4, 5, 6, 7, 8 pieces, so it's 2/8 shaded. So notice in each case we had 2 pieces shaded, but the unit was cut into a different number of pieces. So comparing, again looking from left to right, this is the least amount shaded, and this was 2/8. The next smallest amount was this one, which is 2/6. Then we have 2/4. And finally we have 2/3. So notice for all of these fractions, all of them have a numerator of 2. They have 2 pieces shaded, but they're cut into a different number of pieces. And this sometimes seems counterintuitive, but the more pieces they're cut into, okay, the larger the denominator, the smaller the pieces are. So if we want to compare fractions with the same numerator, we want to use the idea that the larger the denominator is, the smaller the fraction is. So notice these numbers are decreasing, 8, 6, 4, 3. So let's write this general strategy. If 2 fractions have the same denominator and the fractions are positive, we'll see in another video what we can do when they're negative, then the fraction with the larger numerator is greater. So for example, we saw that 3/4 is greater than 2/4. Okay, they have the same denominator, but the larger numerator is greater. If 2 fractions have the same numerator and the fractions are positive, then the fraction with the blank denominator is greater. So that's like the last example. We had the numerators were 2. If we had 2/8 compared to 2/6, we saw that if something is broken into 6, the pieces are actually bigger. We have the same number shaded, but this is bigger pieces. So 2/6 is bigger. So that's the fraction with the smaller denominator. If one fraction is positive and the other is negative, then the blank fraction is greater. So we saw this with integers. Let's just draw a number line. Say this is -3 and this is +3. 3 is greater than -3 because it's to the right of 3 on the number line. The same idea is going to work with fractions. If we have -1/2 and let's put, how about 5/2 just to compare two fractions. We don't even need to compare the numerators or denominators. If a fraction is negative, it's to the left of 0. If it's positive, it's to the right of 0. Okay, so then the positive fraction is greater. And then we have our last note. If two fractions have neither the same numerator nor denominator, we can rewrite them as equivalent fractions with the same numerator or denominator so you can compare them. So if we had something like, say, 1/4 and how about 2/9? Okay. Well, we're not sure which is bigger. Their numerators are different, the denominators are different, so we can write them with a common numerator or denominator. Now, typically, we usually teach to just give them a common denominator, but we can also give them a common numerator, and I think that will be easier since this is 1/4. I can multiply the top and the bottom by 2, which is 2/8. Okay, so 1/4, let me move this over here, equals 2/8. And if I compare 2/8 to 2/9, they have the same numerator. That's why I multiplied by 2. And now we know, well, whichever one has the smaller denominator is greater. So we could see that 1/4 is greater than 2/9. Okay, so compare numerators, compare denominators, compare the sign of the fractions, or rewrite the fractions with a common numerator or denominator so you can compare them.